Hi, my name is Chong. I'm a grade 12 student at Pierre Trudeau High School.
I'm Chen. I graduated from high school. I'm 15.
Hi, I'm Marcel, and I'm grade 12 at University of Toronto Schools.
And we'll be presenting Recap, Intelligent Note-Taking.
So Recap is an intelligent note-taking app that we developed at the MHAX 9 hackathon back in March.
How many of you guys know what a hackathon is? No one? Okay, how many of you guys have been to a hackathon? Okay, so a hackathon is basically a programming competition where students from around the world gather at usually a university. There are general admission ones to build a project. So what we are going to demo today was built in a frenzy of 36 hours of no showers, little sleep, and a lot of caffeine.
All right, so yeah, like you said, hackathons also sometimes come with a theme. And so the theme for the hackathon that we participated in, MHAX 9, was to create something that contained or that pertained to the topic empathy-driven design. And so here's our hack.
Yeah, so the problem that we came up with is we're pretty bad at taking notes. And it's not that we're bad at writing or anything. It's just it's really hard to find a balance between like notes that have a lot of information and are very detail-oriented, and notes that you can write quickly and have like shorthand notes. So personally, when it comes to studying for an exam, I have notes from like 4 or 5 months ago that seem like they don't make any sense to me anymore. They are completely incoherent out of context. So, and a lot of the time I have to like Google the terms and make sense of it. So So this was a problem that we tried to address at this hackathon.
So what we did was a simple online solution. It was a full-featured text editor where you can take notes. We built it off Firebase and React.js, so that included Google Authentication, autosave, and we have these other 2 bullet points: intelligent recording and playback, and Wolfram alpha integration, which you will be seeing in our demo. So that's off. As you can see here, there are 3 of us and 4 people in that photo. That 4th person, second from the left, is Kevin Pei. Unfortunately, he cannot be here with us today because he's suffering through midterms, which is not that bad because he has our app.
Okay, so general overview of the hackathon. So it was like, it was pretty interesting. It was, so one thing about hackathons is hackathons allow you to basically surround yourself with a lot of programmers who are really interested in the same fields as you are in, right? Software development. And so this allows for a great atmosphere for you to actually learn new frameworks or tools or languages. And so one of the main languages that we learned at the hackathon was, it was a framework, was React. And before we went in there, we knew next to nothing about React, but at the end of the weekend, we came out with a pretty nice app.
Yeah, so we actually ended up placing 2nd at the hackathon, as well as winning the Wolfram prize. So, and additionally, if you've never been to a hackathon before, or involved yourself in a hackathon, I highly suggest it, even like a general admission hackathon, because you learn a lot of cool stuff, and it's really fun.
Oh, quick interjection here. There's some hackathons that are global. I know there's one, the Climathon, and there's also a fish hackathon coming up. And so, yeah, those are general admission hackathons.
Okay, so this is our demo. It's currently live, recap.onelab.me in case you guys didn't catch that. I'm going to throw up a new document. And, okay, I'm going to say, what is the professor saying? I'd much rather be asleep. So, and in this, now I'm going to go back. I'm going to hit that play button, and hopefully, it is playing. Is the professor saying, I'd much rather be asleep. So the way our playback actually works, so if I were to start typing here and say, hi, this is a new part of text I am typing. Hi, this is a new part of text I am typing. So this is the difference between our app and kind of just standalone recording, as the problem with standalone recording is that even if you have the recording and your notes, there's no way of matching what you wrote with what was being said when you wrote it. So we kind of solved that problem, and it also does a thing where it saves a separate audio file if you type in a new location. So if you have like a really bad lecturer who jumps around between topics, no problem. Our other feature is that you can actually graph equations, and this is our Wolfram Alpha implementation. I'm not used to this asleep. Used to this keyboard. I doubt Wolfram knows how to understand that.
Just do asleep this time.
I don't know how to click. Okay, sorry. How is it?
It's there.
Okay, I'm gonna go x squared. How do you? Okay.
That won't work.
So this is difficult to select. Okay, so basically you can do anything you want. You can calculate large factorials if you wish.
And so the way this works is we're actually integrating the app with the Wolfram Alpha API. And so you just have to highlight what section of text you may want clarification on, and it'll give you more context on the information. And so in conjunction with the playback and the quick and easy to search tools of our editor, students who are taking notes in class can easily gain context on what the professor is saying. And we believe that this will help students take better notes. And
oh my gosh, this keyboard. Okay. Let's calculate a large factorial. If I can use this touchpad. Great.
Okay.
Curtis, you do it.
So it's like this is one of the things of Wolfram Alpha. Okay, anyway.
Touchpad is broken.
Okay, let's go back to presentation. No, that's fine.
You can always go onto the website yourself if you want to check it out.
onelab.recap.me.
Not responsive, by the way. Don't do it on your phone.
So we encountered a lot of problems, as most software projects do. So one of the issues we had is we wanted to implement speech to text. Obviously, if you're recording a bunch of data, it'd be great to analyze that, maybe get a transcript. Unfortunately, a lot of the speech to text APIs are either really expensive or really bad, especially since the keyboard adds a lot of noise and the laptop microphones aren't very effective. Additionally, when we developed this app, the Node package manager didn't have a lock file. So when we tried to test our app like a few months after the hackathon, all of the dependencies didn't work together anymore. So that was unfortunate.
And another difficulty was when we're trying to align the recordings with the sections of notes that you guys typed, it was really hard to actually maintain that range of characters inside our map of the text editor, because you could actually insert text in the middle of a recording, and that would be a separate recording. So yeah, it was difficult.
Yeah, funny story actually. We found that Bing's speech to text was more reliable than Google's, which we found also disappointing. So what's next? So there are a lot of other features we can add to kind of perfect this note-taking experience. The obvious one here is document sharing, as you already kind of do that, whether you're passing physical paper notes to a friend or if you're sharing on Google Docs. Because we're on Firebase and all the data is stored real time, so every character you type is auto-saved, and should you be typing in another tab, it will update in any other open tabs. So document sharing should be relatively easy to implement. The other thing we really want is formula rendering, because there's this terrible situation we're in right now where we can't do math digitally simply because like writing large fractions can be difficult. Yes, LaTeX exists, but I mean, who uses that to practice math, right? So if we can get a built-in calculator going and a proper Wolfram, like more mathematical integration, we can get a really nice formula rendering system. The other problem is that, well, it's because we can't fix the problem of laptop mics being crappy, we want to create a mobile app that lets you pair it with your web browser so you can actually record the audio with your phone. And of course, finally, we do want speech to text going, as there's a lot of important data that can be gathered from whatever the transcription is. For example, by simply filtering out stop words and finding uncommon words, we can tell you what the teacher was saying and say, hey, there are a few key words that were in your transcription that were somehow missed in your document.
All right, so if you have any questions about our hack or just hackathons in general, now's the time to ask them.
So taking notes in a classroom seems like an ideal application for crowdsourcing type application, either the fellow members of the class or looking up from previous versions of that class. Have you thought about doing anything along those lines?
Yeah, we definitely thought about that, especially with document sharing and even sharing recordings, because sometimes there's noise that happens. Exactly.
Things up a lot.
Yeah, so that was something we were considering. We were still like, there might be privacy concerns, like you need to do it in a certain way. So if a student doesn't attend the class, like they can't get away with other people's notes. But I mean, that's something we've been thinking about for sure.
Hey, that sounds like a great idea. What?
Yeah.
Have you been using this in your classes, or is it not quite there yet?
Well, it's functional. The thing is, we set it up after the hackathon very recently, hence the package problems. No, NPM didn't have a package lock file until like late May. And I don't know if you guys work with NPM, but what happens is that they do this terrible thing where when you install a dependency, it assumes that dependencies will be backwards compatible. And also when you install these dependencies, they install a bunch of other dependencies which aren't added to your package.json and therefore aren't versioned, which creates a lot of problems.
So short answer, no. It hasn't really reached the stage where it's better than like using Google Docs or something, but maybe at some point, we'll see. Yeah.
Can you name the list of technologies and/or languages that you use to achieve?
Yes, we can. So our files aren't, so it's a Firebase backend. So I don't know if you guys know what Firebase is. It's a Google service that acts as a database, but it also has built-in things for authentication, which made it really easy for us to use. Our storage for audio files is actually just on a Flask server. It hits an endpoint and streams the audio to the server and just saved that way with IDs and certain timestamps. And obviously the file name is stored on the Firebase. The entire web view is built with React.
It's no way an ideal setup, but it's something we were able to build really quickly. So it's not super scalable, but in terms of like, we only had 36 hours to build this, so it was pretty quick to make.
One more point to add in, the actual contents of the document were also stored in Firebase.
So JavaScript and Python.
So you have a time series of words. And those words, I think you said, you can actually interpret what the words are.
Yeah.
So you're able to then map, you might say, in terms of temporal proximity, you're able to map these words. And feasibly, you'll be able to construct kind of a concept from that lecture. Is that feasible?
I think maybe. So, I mean, like I said earlier, we were having issues with like speech to text. So at least when I'm writing notes, usually I'm a few lines behind what the professor's saying. So it's kind of hard to tie what the speech, like what's actually happening recorded by the mic with what I'm typing right now. But with the data we do collect from the notes, I'm sure there's some insights that can be gained and connections can be made, especially with the crowdsourcing option, where you could actually connect points together and build up another document.
Sorry, we did actually write a TD-IDF, which we were never able to implement because
TF-IDF.
Something like that.
Term frequency inverse.
Basically, we would compare different notes and we'd find out certain words that stood out in people's documents. So ones that were unique between different samples, and actually based on that, we could theoretically it would be a sort of a mildly, moderately poor model, but it could actually determine which student would have the best notes.
All right, so I think that wraps it up. So thanks for coming to our presentation.
Yeah.